Good morning, children. Let me ask you a few questions. Have you any time tasted lime or by chance soap water? Or you might have also observed some people taking antacid tablets such as Eno. Yes. What are the questions I asked? Did you any time taste lime? If you have tasted lime, what is its taste? Yes, it is sour. If you have by chance tasted soap water, by chance it has touched your tongue and etc., you might have observed that the taste would be or will be bitter. Now, why are some people asked to take these antacid tablets? Because usually they suffer from indigestion. Yes. So, these examples have got to do something with classification of substances. So previously, based upon the taste, chemists have classified substances into three kinds, namely acids, bases and salts. This is based on what? Based upon taste, chemists have identified the substances as or classified the substances as acids, bases and salts. Acids usually have sour taste. Bases usually have bitter taste. And you know, salts what it would do. When I say salt, the taste itself is salty. So in this topic, we are going to discuss about what are all these called acid, bases and salts. What are these? What are their characteristics or what are their properties? Where do we use them? What are its applications? That is what is the topic to be dealt about. Yes? Or in the beginning, acids were identified by their action upon a chemical substance called litmus. They used to identify acids using a chemical substance known as litmus. At the same time, bases are also identified using this litmus. So to identify an acid, they used blue litmus, and to identify a base, they have used red litmus. Possible.
First
Now look at this substance. So I have taken a solution in the test tube. Yes. Now if you observe carefully, what is the color of the solution? It is clear. So because it is clear means this solution is colorless. So I will take this colorless solution into a other test tube, small amount. And add to this, you observe this one. If you observe this solution, this is blue in color. This is blue in color. So this blue color solution, I will add it to a colorless solution. You can see what has happened. It has turned red. Okay. So the blue solution which I have taken in this test tube is the blue litmus solution. So when it is added to the colorless solution, it has turned red. Okay. So just note down this observation. The blue litmus has turned to red in one of the colorless solution. Now what is this colorless solution? I will let you know. You see this? There is one more colorless solution. Okay? So I take it into a test tube. And to this, I add a colored solution. Now you observe this is red in color. So let us add this to the colorless solution. You see what has happened? It has turned blue. Okay, so make the observation of this. So the initial solution which I took was also colorless, and the second solution which I took also is colorless. But to these two colorless solutions, when you added the litmus, there was a color change. So in the initial one, what you have observed, it has turned the blue litmus to red. In the second solution, what you have observed, it has turned red litmus to blue. So I was already mentioned previously, acids are the substances that turn blue litmus red. Bases are the substances that turn red litmus blue. That is, initially they identified acids and bases based upon the color change that happens in presence of litmus. Apart from that, the other one is the taste. So what taste will acids have? Sour taste. What taste will bases have? Bitter taste. So what was the identification? Initially acids were identified by their taste, namely sour taste. Bases were identified by their taste, namely bitter taste. This is one way of identifying acids and bases. And what is the second way of identifying acids and bases? Acids turn blue litmus to red, and then the bases turn red litmus to blue.
Correct.
Now, apart from identifying the acids and bases based upon their taste and their effect on indicators, now the later on experiments have also defined acids based upon their behavior when dissolved in water. Okay. What's the first method of identifying acid and base? Taste. What's the second method of identifying the acid and base? Using the litmus. Now, the other way to identify acid and base is their behavior when they are dissolved in water. Okay? So, now based on that concept, acids are substances. Acids are substances that dissolve in water and liberate hydronium ion. Liberate hydronium ion as the only positively charged ion. You can make the note of this statement also. I will read it once again. What are acids? Substances that dissolve in water and liberate hydrogen ions as the only positively charged ions. So let me take an example for this. For example, an acid like HCl. An acid like HCl. When this is dissolved in water, this acid dissociates to form H3O plus and Cl minus ion. HCl, when it is dissolved in water, it dissociates to form H3O plus and Cl minus ion. So let's take another example. H2SO4. When H2SO4 is dissolved in water, it forms 2H3O plus and SO4 2 minus. SO4 2 minus. Or say if I take another example like H1O3. When this is dissolved in water, this will form H3O plus and NO3 minus. So if you observe these three equations carefully, in all the three equations, hydronium ion, that is H3O plus ion, is a common ion. And that too, it's a common positively charged ion. But when it is negatively charged ion, you see there is a difference. Yes? So, what's the negatively charged ion produced in case of HCl? It is Cl minus. What's the negatively charged ion produced in case of H2SO4? It is SO4 2 minus. What's the negatively charged ion produced in case of HNO3? It is NO3 minus. So, are the negative ions common or the positive ions common? So, if you observe carefully, the positive ions is common. So, that is what is the statement. What are acids? Substances that dissolve in water and liberate hydronium ion. So, hydronium ion is nothing but the H3O plus ion. So, H3O plus ion is common. Okay. Now, this is a definition of an acid when it is dissolved in water, or you are defining the substance called acid with respect to its behavior when it is put in water or dissolved in water. Yes. You can note down these equations too. Now coming to base. Now how you define base? A substance that reacts with an acid to form salt and water. What is a base? A substance that reacts with acid to form salt and water is known as a base. So, for example, say MgO. Now, this can react with an acid like HCl and forms NgCl2 plus H2. Or say ZnO with say H2SO4. This can form ZnSO4 plus H2. Now, if you observe these two equations carefully, MgO, magnesium oxide, it's reacting with HCl, that is hydrochloric acid, to form MgCl2, which is salt and water. Similarly, ZnO is reacting with an acid, that is H2SO4, to form ZnSO4 and water. Now, in these two reactions, the substances MgO and ZnO are named as bases because they are reacting with acid to form salt and water. Yes. Now, there are some bases which can dissolve in water. Now, when these bases dissolve in water, you call them as alkalis. Now, MgO and ZnO, you are naming it as base. But this substance called MgO and ZnO, it cannot dissolve in water. But if a base is dissolved in water, then it is known as an alkali. So what is alkali? A base that dissolves in water and liberates minus ions as the only negatively charged ions. What is the base that dissolves in water and liberates OH minus ions as the only negatively charged ions? For example, say NaOH. Now, this NaOH can dissolve in water and form Na plus and OH minus. Say KOH. This also dissolves in water to form K plus and OH minus. Or say another example, NH4OH plus H2O. They get dissolved in water to form NH4 plus and OH minus. Now in these three equations, what is the common ion produced? The common ion produced is OH minus. What is OH minus called? OH minus is known as the hydroxide ion. So the common negatively charged ion produced is hydroxide. But the positively charged ion that is produced here is not a common ion. But when you compare with that of acids, which was a common ion? Positively charged was a common ion, negatively charged ion was not common. But in case of an alkali, negatively charged ion is a commonly produced ion, that is hydroxide ion. But the positively charged ion produced is not a common ion. Now let us once compare the alkali and the base which I have defined. So what is exactly the difference between the base and the alkali? So for example, then we get a clarity related to base and alkali. Say MgO is taken twice. These two are bases. Why? Because they cannot dissolve in water. But NaOH, KOH, these two can dissolve in water. Not only they dissolve in water, they liberate OH minus ions, and hence it is an alkali. So you compare this formula and this formula. There is OH present here, there is OH present here. So because there is OH present, the common ion is the OH that is present. But what is the basic difference? MgO is taken twice, even though it contains OH, it does not dissolve in water. Means it is a substance that is containing OH but not soluble in water, you call it as a base. But it is a substance, it contains OH and it dissolves in water to liberate that OH, then hence it is called alkali. Yes. So in base and alkali, what is common? OH is common. Yes, in base and alkali, what is common? OH is common. Therefore, an alkali can be named as a base. An alkali can be called as a base. But all bases are not alkalis because they don't dissolve in water. So there are only three alkalis. One is NaOH, KOH and NH4OH. Now remaining all others are bases. For example, if I write ZnOH taken twice, it's a base. Why is it a base? It contains OH but it does not dissolve in water. When it doesn't dissolve in water, it cannot liberate OH minus. Similarly, say AnOH taken twice. It's a base. Can I call this as an alkali? No, because it does not dissolve in water. Now it's easy to remember. There are only three alkalis: NaOH, KOH, and NH4OH. So why are you calling these as alkalis? Because it can dissolve in water. Are these three bases or no? Yes, they are bases because even they can also react with acid to form salt and water. But these substances, they are bases but not alkalis because they don't dissolve in water to liberate the OH minus ions. Is it clear? Yes. In the beginning I told you, one of the way to identify acid and base is using litmus, blue litmus and red litmus. Now these blue litmus and red litmus both are examples of indicators. Okay? What are blue litmus and red litmus? Both of them are example of indicators. Now, what are these indicators? Indicators are chemical substances. Chemical substances. They are usually dyes. Dyes that undergo a color change, or may not undergo color change, in presence of acid or base. So what are indicators? Chemical substances, usually dyes. You might have aware of dyes, DYES, which undergo color change, or they may not undergo color change in presence of an acid or a base. So already I demonstrated using litmus. Let me take other indicators and give a clarity. Now, the indicator in my hand named as phenolphthalein. Okay, so I'll just take this into a test tube. And you observe what is the change. See, the solution has turned pink. Okay. So originally this substance was white. In presence of base, what has happened? It has turned pink. Okay. And then again I am adding acid. Pink color has disappeared. So in presence of acid, the color has disappeared. Now I am taking another indicator. This is called methyl orange. It's originally orange in color. It's originally orange in color. Okay. So I will add acid to it. It has turned red. Okay, it has turned red in presence of an acid. I'll take the same with the let's add base. You see it has turned yellow. Okay, it has turned yellow. So I have used two indicators here. Initially I used blue litmus and red litmus. Next I have taken two more indicators, namely phenolphthalein, and you have seen they have undergone a color change. So based upon the color change, you are concluding whether a given substance is acid or a base. So apart from that, you can also use turmeric as an indicator. Yes. So litmus can undergo color change in presence of acid and base. Methyl orange can undergo color change. Phenolphthalein can undergo color change. Turmeric also can undergo color change. So I'll just tabulate it on the board how the color change happens. We can note it down. Okay. So as I told you, what are indicators? Chemical substances that undergo a color change in presence of acid or a base. base. Therefore, they can be used to identify a given substance as acid or a base. So, based upon the source, indicators are of two kinds: natural indicators and synthetic indicators. Okay, based upon the availability, one is natural, the other one is synthetic. So, natural indicators means they are available from natural sources. Now, litmus is available from lichens. Turmeric is available naturally, you are aware. Yes, and red cabbage, if you are familiar, the red cabbage is originally purple in color. So, litmus in presence of an acid, blue litmus turns to red. In presence of base, red litmus turns to blue. Turmeric, which is originally yellow in color, in presence of acid, it remains yellow. In presence of base, it turns from yellow to brown. Red cabbage, which is originally purple in color, in presence of acid, it turns red, and in presence of base, it turns green, from purple to green. So these are the examples of natural indicators. So when it comes to synthetic indicators, so what are synthetic indicators? Man-made indicators. Means these are the indicators prepared in the lab. Yes. So two categories, two examples: methyl orange and phenolphthalein. So methyl orange is originally orange in color. So in presence of acid, it turns from orange to red, and in presence of base, it turns from orange to yellow. Similarly, phenolphthalein, which is white or colorless, in presence of acid, it remains colorless. In presence of base, it turns pink. So in this way, you can use natural indicators and synthetic indicators to identify whether a given substance is acid or a base. So you can note down these two tables and just go through the concepts thoroughly. And further topic will be continued in the next coming videos.